We are trying to integrate from 2 to 3 this particular function here, 1 minus by 2x, all to the power of 3 there. Now, it looks kind of funky. There's this like 1 minus 2x business in there. It seems, yeah, kind of tricky to do. So let's just simplify it. Let's just say, well, what is the integral of just something like x to the power of 3? Okay. Now for us, right, when you integrate, you go up. When you differentiate, you go down. So we're going up, and we put a 1 there, and we divide by that 3 plus 1, which is 4. Okay, and technically you can write a plus c. So our final result here would be like this. Okay. Now, the tricky thing is that in our integral original one, we've got this 1 minus 2x business. So what happens if we try and differentiate that, right? So let's stick it back in. So we stick 1 minus 2x, and we just try and differentiate it. Well, what we can see is that the 4 goes down to the bottom. We're using the chain rule, right? So if you haven't done that before, I'd recommend looking at some other questions. But for this one, the 4 goes down to the bottom, and that kind of cancels out that bit. But we're left with the inside bits where we need to find the differential of that. So this guy here, that 1 minus 2x, we're going to try and differentiate just that component. Okay, just differentiate 1 minus 2x, and we see that we're left with just a minus 2. And so this whole thing gets times by minus 2. Right? And that doesn't look the same, does it? So we've got this minus 2 out the front now. And I don't know about you, but that does not look the same as our original question. So what we're going to have to do here is we're just going to have to divide by minus 2 as well. So this is how I like to do it. I like to integrate it and then differentiate it, use the chain rule, and then see what's different about it. And I can see that there's this pesky minus 2 that I also need to differentiate with. So this is equal to that the guts of it stays the same, goes up to 4, we divide by 4, but we also need to divide by minus 2. And that's the trick. Once you've gotten past that, you've done the majority of the effort. So the integral is trying to find the area under the curve. It is the top minus the bottom. Let me simplify everything, and then we can stick in a 3 wherever we see an x, and a 2 on the other side. Okay, so it's this value here. So wherever we see an x, we're going to put in that 3 value. So I'm going to leave all the brackets in, and I like using the brackets here because if there's any negatives, I don't make a mistake. Okay, and then minus this value. Oh, it's going to get a bit squishy. Okay, so let's simplify this. There's kind of a lot going on here. So that 2 times 3, which is equal to 6, or the power of 4 there. And we say that that's 1 minus by 4, or the power of 4 there. And let's just work it out by saying that 1 minus by 6 is equal to 5, minus 5 specifically. And this one here is equal to minus 3. Now, it's only 2 marks here, so we're probably going pretty far down the rabbit hole, but we're going to need to simplify quite a lot of this, right? And so to do that, it's a bit some crazy math. So I think that this is probably outside of a non-calculated question. However, it was a previous exam question. So 5 times by 5 is 25, times another 5 is 125, times another 5 is 625. Okay, so it might take you a while to get that, but it becomes minus 625, and then minus sign, there's an even amount of them. So minus 5 times minus 5 is positive, times minus 5 times minus 5 is also a positive. So we're just going to leave that as a positive there. All right, I'm going to simplify this. So see how there's those two negatives there. They come together and they make a plus. And now we've got minus 3 to the power of 4. Okay, 3 times by 3 is equal to 9, times by 3 again is equal to 27, and then you can do your long multiplication if you need to, and I'm just going to show you how to do that again. So we go 3 times by 7, which is 21, plus 3 times by 20, which is 60, and that means that our final result here is going to be equal to 81. Okay, so that's 3 to the power of 4, which is a bit horrendous. Again, it's even, so it's going to be 81. Okay, and that's all divided by 8. And so we can put that all together, remove the brackets here, and we can say it's all divided by 8, and that's 81 minus 625. Okay, the math here is pretty insane, so let's figure it out. I'm going to just flip that around to make my maths easier, but it's the 4, so 5 minus by 1, which is 4, and then the 2 minus by the 8, so we get rid of we got 6 remaining, and we take 1 off the top there, so it's that, apologies. So we get the 1 from the 6 there, so that becomes a 5, and 12 minus by 8, which is 4, and then that becomes 544. That's just the absolute value that I've done, but because it's the negative side is bigger, so on our number line, we've got 0 here, we go back by 625, and we go forwards by only 81, we're left with minus 544. So that's our final result. It's a lot of mental maths, probably outside of the scope of a non-calc question. However, it has appeared before. So our final result is this one. You probably don't need to simplify it any further. You can if you want. You can just keep dividing it by 2. So for instance, I can just take a 2 out of the bottom bit and then a 2 out of the top bit. So let me figure that out. So that becomes 500, this all divided by 2. Long division again. We've got 2 in there. We leave 1 over. We've got a 7 in there, and then we've got a 2 in there. So it becomes 272 times by 2, and we can cancel out those 2's. And you can go one step further. It's still even at the top. It's still even at the bottom, and you can keep on going. But there's no need, really. You don't need to keep going. But if we keep going, we'll eventually get to a result of minus 68. So that's it. If you have any questions, reach out. I'd love to help. There's so many more questions available on my website. You can practice forever and get really good marks.